Okay, welcome to the lesson on the angles between lines, and we're going to say in R2 right now, but this will apply to lines in R3 also, provided they intersect. So we'll just look at an example. So look at this example, two lines, R1 and R2. So this is in the vector equation. This is the vector equation. Oh, one point. Normally, we use t as the parameter. If you have two lines, the next common parameter would be to go with s. So I used s instead of t because I already have the t up there. So when we want to find the angles between two lines, right? So what does that mean? Well, you got two lines. Looks like that. And you might point out there's actually two angles, right? There's this angle theta, and there's this angle alpha, and theta plus alpha equals 180. And you'd be right, there are two angles. That's why I put angles with an S there. A lot of the times, we're only asked for one. Sometimes it will be more specific, and we'll say find the acute angle. And if they only ask for one, a lot of times they mean the acute angle, but they don't say. And sometimes you'll notice in the back of our book, at least, they give one and they don't, there's no reason why. One is not better than the other. It could be both. So how are we going to find the angle between two lines? Well, all you have to do is look at the direction vectors, right? If this was M1 and this was M2, kind of looks like that, right? M1, M2. Well, then the angle is just the angle between the two direction vectors. So just find angle between direction vectors, and that's a piece of cake. Right? We know that formula. We should know it fairly well. Theta is equal to cos inverse of, so two direction vectors, we'll call it M1 dot the other direction vector, we'll call that one M2, over their magnitudes. Okay, so for this example, we'll just do M1 dot M2 was 23 dot minus 14. So that's equal to minus 2 plus 12 equal to 10. So that's the dot product. We'll calculate the magnitude of the first one. So it's the square root of 2 squared plus 3 squared. So that's the square root of 4 plus 9, or square root of 13. And we'll calculate the magnitude of M2. So that's the square root of minus 1 squared plus 4 squared. So that's 1 plus 16, or root 17. So theta is equal to cos inverse of M1 dot M2 was 10 all over root 13 times root 17, and then you just work that out on your calculator. So when I did that on a calculator, I got 47.7 degrees. So there's your angle between the two vectors. When it's in vector equation form, but what if, let's say you were given two Cartesian forms, 3x plus 2y minus 1 equals 0, and I don't know, minus, oh no, it always should start with a positive. So we'll say 2x minus y plus 1 equals 0. Okay, so now we're given two lines, but we don't know the direction vectors. We only know this. Well, what do we know actually? We know the normal vectors. And if you think about it, the angle, this is normal to this line right here, and this is normal to this line. Well, that angle should be equal to that angle. So the angle between two lines is also equal angle between lines is equal to angle between normals. Okay. Ooh, before I go any further, just let me let me go back to that last example. 47.7 was the angle we got. That was the acute angle, right? You might have, and actually, if you had taken a different direction vector, if you multiply this by -1, you would get 180 minus this, and that's right too. Okay, so if you're ever doing a question, you check the back of the book, and you don't get the same answer, check 180 minus, and maybe that's right. Okay, so now let's just look at the the normal vector. So normal 1. Remember, normal is just the coefficients 3, 2, and normal 2. So that would be the coefficients to -1. There you go. There's your two normal vectors. So we just need to figure out the angle between these two things. So that's n1 dot n2 all over magnitude of n1 magnitude of n2. Okay. So right, I'll do it. Cos inverse of, so n1 dot n2 would be 3 times 2, 6, minus 2, all over the square root of the magnitude of this, so 9 plus 4, 13, and the magnitude of this one, 4 plus 1, 5. So it's equal to cos inverse of 4 over, just to make this easier, root 65. And I'll put that all in my calculators, see what I get. I got 60.3 degrees. So that's the angle between, well, it's the angle between the normals, but also the angle between the lines, the direction vectors. And of course you might have got 180 minus this, which would be 119.7 degrees. So you could have got that one too. Both are right, both are acceptable, unless they say find the acute angle, then only this is right. And if you did get this, and they ask for acute angle, you better change it to this. Okay. But otherwise, both are fine.